In this video, I am going to simplify these imaginary/complex numbers. Let's start off with I. By the way, I is defined as square root of -1. Where does it come from? It comes from actually trying to solving this equation. So let's say you have x squared plus 1 is equal to 0. You want to solve for x. That means you're asking the question, what value of x will satisfy this equation? So what we do, we just do the usual stuff. We subtract 1 from both sides. That gives me x squared is equal to -1. Now we ask ourselves the question, what value of x will give me -1 when I square it? So we look into our familiar number line, 0 here, positive numbers here, and negative numbers here. Please note that obviously, here if we look at this number line, we have three types of number, generally speaking. Positive numbers, negative numbers, and 0, which is in between, neither positive nor negative, or sometimes we say it's both. So obviously, if I take 0, 0 square is not equal to -1. 0 square is 0, right? If I take any positive number, doesn't matter what it is, let's call it a square. If a is positive, a square is also positive, meaning it's greater than 0, which means that's not equal to -1. What if I take a negative number, any negative number? So let's say, let me give you an example like -1. It doesn't matter, you can pick any negative number. If you square it, -1 whole square is -1 times -1 is equal to +1, which is obviously not equal to -1. Which we are looking for right here. So we have exhausted all the numbers on the number line in trying to find a solution for this equation. So it doesn't exist. So what we do, basically, we do the following. We take the simplified equation x squared is equal to -1, and then we try to solve it as if like we are solving a regular equation, and we take square root of it. So this square and square root is going to cancel. That's going to give me x is equal to square root of -1. Now this square root of -1 is a number that does not belong to this real number line. The number line that you are familiar with, we call it real number line. So it doesn't belong to real number line, so we get creative, really. We give it a name. I is called imaginary number. So I is equal to square root of -1. So that's this one. Now if I square I have to square both sides, square root of -1 square. So that gives me I square is equal to square root cancel out -1. So remember these values, these are special values. I is equal to square root of -1, I square is equal to this. How about I cube? I cube is gonna be just I square times I, but I already found out that I square is -1, so this is going to be -1 times I, which is just -I. So I cube is equal to -I. So that's another special value. Then I to the power 4 is easy one. I to the power 4 is equal to I square times I square, which is -1 times -1, because I square is -1, which is just 1. So I to the power 4 is equal to 1. So these are 4 special values that you may want to remember. So these are the first 4 ones. Now pick any number, integer value greater than 4. Let's say I to the power 5 is going to be I to the power 4 times I. But I to the power 4 is 1. So it's going to be 1 times I, just I. I can take I to the power 10, this one, doesn't matter. I to the power 10 is equal to I to the power 8 times I square. How did I come up with 8? 8 is a multiple of 4. Okay? So that means what's going to happen, I could write I to the power 8 as I to the power 4 whole square, right? Because 4 times 2 is 8 times I square. But I know I to the power 4 is 1. So 1 square times I square, which is 1 square is 1. So 1 times I square is I square. But I square is -1, we already know. So -1. So interesting observation is this. If you take any integer power of I, any integer power, let's say I to the power n, where n is an integer. Okay, I didn't do a good job in writing here, by the way. So if n is an integer, it's going to be one of these four values, either this, or this. You can see I just pick I to the power 2017. I'm going to rewrite it as I to the power 2016. Why 2016? Because 2016 is divisible by 4. So this is just, anytime you have an exponent of I that is divisible by 4, this whole thing becomes just 1. Remember that thing. Anytime you have an exponent of I that is divisible by 4 is going to be just 1. So I to the power 2017 is equal to I to the power 2016 times I. I is the same as I to the power 1. So 1 plus 2016 is 2017. But this guy is just 1, so it's going to be just I. So I to the power 2017 is just I. Then I to the power negative 2020. By the way, this number is divisible by 4, so it's just going to be 1. You don't have to do anything else. If you want to see the details of how you get it, I showed it here, but I'm going to show it to you here again. I to the power 4 to the power negative 505, because negative 505 times 4 is negative 2020. But I to the power 4 is 1, so it's going to be 1 to the power negative 505. But 1 to the power any fixed number is always 1. So that's what it is. Okay. So keep in mind the important parts, which are this: I is square root of negative 1, I square is negative 1, I cube is negative I, and I to the power 4 is 1. And then if you know these four values and using the property that I to the power 4 is equal to 1, you can simplify any I to the power n where n is an integer. Okay, I hope that this discussion was helpful. Thank you very much.